Saxon Algebra 1 Lesson 67. A lesson you're going to remember for a good long time. We've been talking about systems of equations. When you have two equations and they both have, usually we have an x and a y, but they have two variables in them. And we solve them together, right? We find a value for x and for y that works in both equations. And we call that solving a system of equations. And there are, in total, in high school you will learn 5 different ways to do that. Okay? We're going to learn all 5 of them. If you stick with me through advanced mathematics, you will learn all 5 ways. The first one we have already learned. It's called substitution. And you know how that works. We take one of the equations and we rearrange it so that it's either y equals or x equals. And then we take that thing that it's equal to and we plug that in to the other equation. We substitute, right, the value for x into the place of x. Now, the second method we're going to learn today. It's called elimination. Look, right there. That is the second of the 5 ways. And what we're going to do is we're going to spend a lot of time practicing these 2. The third way, I think we learned this year, it is elegant and it's very visual, but it's not very practical. We're going to find these 2 are our tried and true ways to work on solving a system of equations. We'll fill these in as we go. I don't want to give you too many teasers because you'll just be so excited. We don't want to wish away Algebra 1. So let's look at how that works. When John gives us the equations for these, which I'm doing right now, I'm copying. Okay, you just make sure I copied the problem, right? Yes. Yes, okay, and it's a system of equations, so it has the bracket on it. We see immediately, oh, how would we do this with substitution? Well, we'd rearrange this one because we'd get this y by himself. He's the guy with no number in front of him. We'd swim him over here, we'd push the 13 over there, and then we'd plug that in right there where the x is. This time, completely different strategy. What we're doing this time is we're lining up the equation so that we have x term, y term, equal sign, plain number. Okay, that's the way we want them to be formatted. And John does a nice job in this lesson of giving us exactly the way we want. What we get to do is choose. Do we want to eliminate the x's or eliminate the y's? And what I mean by that is we're going to adjust the equations so that whichever variable we choose will have the same number and the opposite sign. Then what we're going to do is we're going to add these 2 equations together. Yeah, I didn't know you could do that either when I was just learning this. I was like, what? You can add the equations? Yeah, you can. When we add them together, they will cancel. Okay? Now we look at this and go, well, 2 and 3x, those are not the same number but opposite signs. And here we have minus, technically a -1, right? And a +4, those are not going to cancel. The numbers we don't cancel, we cancel one of the letters. But here's the cool part. We can adjust the equations. We can take either or both equation and multiply it by either a number or a sign, or both, and create 2 equations that will offset. I know, mind blown, right? So what I look at, I'm looking at the y's right here. And what I like to do is I like to draw an arrow to the one I want to eliminate. I see that if I multiplied this top equation by 4, then I would have -4y and +4y. I like it. So if the numbers aren't helping me out, I look at the signs too and think, okay, how can I use this perfect mix of positive and negative to give me what I want? So I've decided I'm gonna multiply the top equation. I'm gonna do it in a different color because it just helps you see a little bit what I'm doing. I'm gonna multiply the whole equation by 4. That will give me, now I have to multiply all 3 parts, right? I must be vigilant. 8x minus 4y equals, let's see, 4 times 3 is 12, plus 40, that's 52. Okay? So what I have done is I have changed equation, let's call it A, and let's call this B. I've changed equation A by multiplying it by 4. So I'm now going to call that 4 times A. Now, this is my new system of equations, right? Because he got morphed into him. So it's still that first equation, right? That's why it helps sometimes to do the letters. Now, I'm going to add. So our first step was adjust equations. And I'm going to write this in plural because if we want or need to, and you'll see it later, we can adjust both, right? This time we only had to multiply the 1 and we created the perfect pattern. Sometimes you do both. So we adjust the equations. Then the second step is we add them together. 11x, ooh, happiness, equals 55. And then the third step is we solve. And it's pretty easy at this point, right? So we get x equals 5. Happy days. Now, just like we've done in the past, we have to take this value and we have to plug it back in to one of our original equations. Here's the good news. We can use A, or we can use B, or we can use this one that we created, 4 times A. Now, I don't know why we would want to, because this just has bigger numbers. I like this one because it's got the simplest numbers. So we're going to plug into this. I'm going to have to turn the page. 3x plus 4y equals 3, and then x equals 5. 3x plus 4y equals 3, and then we got x equals 5. This looks like one of those problems that we did forever ago. We started doing them where you plug a value into an expression. It's the very same idea. So this would be 3 times 5 plus 4 times y equals 3. This is 15. So we're going to subtract 15 from both sides. And we get 4y equals minus 12. All right. There's a minus sign there, but I'm okay with it. Y equals minus 3. So let's take that back over here. And we'll write that the solution, I can do it on this side. I want to come back to this, but let me, x equals 5. So our pair of ordered pair, our pair of values, our point where these two lines intersect is 5 minus 3, and that's the correct answer. I forgot to tell you the first thing. Pick a variable. That's the first thing that we do. Then we adjust the equations. Then we add them. Then we solve. And then we solve for the other. Right? In this case, we solved for x first, and then we went back and did y. I will say this many times probably, but I'm going to say it again. It doesn't matter whether you solve for x first or y first, okay? Whichever you think is easier. And you don't have to think too far ahead, right? When we were looking here, we weren't thinking about how all that work was going to go. We just said, okay, which is going to be easier which of these values will it be easier to adjust the equations to make them cancel out? Should we adjust the y's or the x's? We could have multiplied this one by 3 and this one by -2. Oh, then we would have gotten a +6 and a -6. So you can do it either way. It's risk-free in that respect. All right, let's try another one. And let's see how many there are. There are 4. So this is example 67.2. Solve by using the elimination method. Oh, excuse me. So John tells us in the instructions now which way he wants us to solve it. He's forcing us to practice because most students feel more comfortable with substitution and they avoid elimination because it's new and scary. So he's going to make you use elimination. But I'm happy with that because you know what? Once you get the hang of elimination, it works really, really, really well. And I kind of love it. I once was riding the bus. This was probably before you were born. This was probably in the early to mid 2000s. I'm riding the bus and it was, I don't remember exactly where I was coming from, but the bus was full of students from what was then Edmonds Community College, right? So there were a lot of students on the bus. And I was sitting behind 2 girls who were probably like 17, 18, 19, something like that. And I eavesdropped on their conversation because I was so fascinated by it. They were having a conversation about which is their favorite method of solving a system of equations. And they were debating back and forth about which was better, substitution or elimination. And I thought that they were the cutest, most adorable creatures in the entire world. I just loved it. So, now you know how weird I am. Okay, here's our new system of equations. First step, we decide which variable we want to eliminate. So I'm looking down the columns. Again, John has given us just a very neat and tidy set of equations. Everything's all set up perfectly. So I can see that we're going to have to adjust both equations this time, right? Because the x's won't eliminate. I would have to multiply this one by, I'd have to get them both going towards 6, right? And one positive and one negative. So I'd multiply this one by 3 and this one by -2. If I have to put the negative in, I usually put it in the bottom. Okay? It just looks more normal to me. But it's okay if it's in the top. But I don't create it that way. If John does it, that's fine. And that's what he's got going on over here, right? We've got the negative and positive we like, but we're going to have to adjust the numbers. 12 is where we're going to go, right? This one by 4, this one by 3, but the minus signs are already good. I will be very happy to use minus signs that are set up properly because multiplying by a negative number, like I would have to do if I chose to eliminate the x's, I'd have to multiply this by a negative number. That just sets you up for mistakes. Let's not do it. Okay, so I've decided that I'm going to multiply the top one by 4, and then I'm going to use different colors so you can follow what I'm doing. And then this one, I'm going to have to multiply by 3, right? So now let's rewrite them. So this one's going to be, and this is the green one, so 4 times a is what I'm going to write here. Again, I have to make sure I distribute to all 3 places. So that's going to be 8x minus 12y equals 20. That's an 8. This marker is skipping a little bit. Okay, 8x. Okay, so I multiplied all 3 parts by 4. And now I said I'm going to multiply 3 times b. So here comes 3b, and that is 9x plus 12y equals, okay, let's multiply this. 3 times 8 is 24. This would be minus 54. I multiply the ones place. That's 3 times 8 is 24. And then I multiply this really quickly in my head. 3 times 10 is 30. 30 plus 24 is where I get the 54. All right, so now I have adjusted both of my equations. And this one I had to do both, right? Now I'm going back to just my plain orange and I'm gonna add them. Yay, this cancels just the way I planned for it to. And I get 17x equals, minus 34. That's what I was hoping. I was hoping we would get a 34 out of this because I know 17 times 2 is 34. X equals minus 2. I will say this, John does a lovely job of giving us nice, cute answers. We very, very rarely get fractions in these. He almost, or big numbers, like, 27 or something like that. He almost always gives us single digits, plus or minus. But he gives us cute, cute, cute little numbers. Okay. So we've solved for x, now we're going to plug back in and solve for y. We can use either of these equations or either of these. Any of the four is just fine, it will work. However, like I said, when we multiply the equations up to get them to cancel, we just make the numbers bigger. So why would we want to do that? I'm going to choose A. So it will be 2 times minus 2 minus 3y equals 5. This is minus 4, so I'm going to add 4, and we get minus 3y equals 9, and we get y equals minus 3. So my final answer, I'll write it up here. No, I'll write it down here. Minus 2 minus 3. Right? Yay. It's the right answer. Did I? This was the right answer too, yeah. Okay, so decide which ones you want to eliminate. Adjust the equations by multiplying. Add them together, solve for the first letter, and then plug in and solve for the second letter. Let's do another one. As you can see, these problems they take a while. They're kind of long. Solve by using the elimination method, but this time, eliminate y. Okay, so it's the very same set of equations. 2x minus 3y equals, I'm going to change those instructions. This is the same system that we just used. When John did the last problem, he chose to eliminate the x's. We chose the y's last time, so we'll choose the x's this time. He just wants us to practice and see how you can do it either way. So this time we don't get to choose. We're just going to automatically do the x's. All right, so how are we going to adjust these? Well, we're going to make them both 6, right? Because that's the number that these two have in common, the lowest number. It's the lowest common multiple. Or least common multiple. That's the other word we can use. Okay, I'm going to put the minus down here. So I'm going to multiply the top by plane 3, positive 3. And I'm going to multiply the bottom by minus 2. Right? That'll give me a 6, and that'll give me a negative 6. Beautiful. So this is my A equation and my B equation. Now, I'm going to take 3 and multiply it by A. So this will be 3 times A. Again, I'm going to distribute. And I'll have 6x minus 9y equals 15. And then I'll distribute the minus 2. And I'll have, and this is minus 2 times b, right? I just keep track of what I'm doing on the side here so that I can kind of follow my own thinking. This will be minus 6x minus 8y equals minus 36. All right. So we've adjusted both. Third step is to solve. The x's cancel. Remember last time we did the y's, but this time the x's cancel. We get minus 17y equals, oh, this is positive, my bad. Minus 2 times the minus 18 rather, sorry, is positive 36. So these two added together give me 51. Divide both sides by 17, and yes, that does come out even. I know it's not going to be a very big number because 51 is not that much bigger than 17, so I know it's going to be a small number. It's not 2 times 17 because that's 34, but what about 3 times 17? So I do that in my head, 3 times 17. 3 times 7 is 21. 30 plus 21 is 51. So I know that y equals negative 3. Okay, great. Now we'll plug back in. I'll use the first one again because, again, I just like the numbers better. I don't want to deal with an 18. 2x minus 3 times minus 3 equals 5. This is a 9, so it's a plus 9. So we'll subtract 9 from both sides. Do you see, instead of writing the whole equation over again, I just make a little note to myself as to what that number represents. It's perfectly fine to do that. We have enough experience in solving equations now that it's okay if we take an occasional little shortcut like that. I do always write that down though so I can remember my thinking. 2x, this all cancels, equals minus 4. X equals minus 2, right? And so our final answer is minus 2 minus 3. And ready? What was the answer to our last one? Minus 2 minus 3. Yay, we got the same answer. So the moral of the story is it doesn't matter in terms of getting the problem right. It doesn't matter whether you choose to eliminate x first or y first. It'll work out fine. Just do whatever looks easier for you. Okay, one more. Use elimination to solve the system. 2x plus 5y equals minus 7. And okay, there's our system, A and B. These letters are here just to help us talk about the equations. They don't have any mathematical meaning. Okay, what would you like to do? Again, I go, okay, well, that would be fairly easy to adjust. We would make them both 6. Multiply this one by 3, this one by 2, but we'd also have to throw a minus sign in there. I'd put it on the bottom, and we would have to multiply by a minus sign. Ugh, I mean, that's fine. We can do it. But I see this, and I go, okay, this is equally cute. This we would make 20, right? This times 4, this times 5. But here, I would not have to use a minus sign. So I'm going to choose this one. I'm going to choose to eliminate the y's. Okay, so I'm going to multiply the first one. Let's see, I would need to multiply the first one by 4. So that'll be 4 times a. And then I'm going to multiply the second one, all 3 parts, by 5. And that will give me, there's the 20 and there's the 20. Okay, let's go. Ready? Here we go, multiplying. 8x plus 20y equals minus 28. I didn't draw the distribution lines this time. You'll have to imagine them. And now 5 times, that's 15x minus 20y. I always check to make sure it really did eliminate itself, that I chose the right numbers. Sometimes you'll just, be crazy for a moment and choose the wrong numbers and you'll catch it right here. And then 5 times 1 is 5. Okay, That's kind of weird, but all right. Ready? Now we'll add them. 23x equals, oh my gosh, minus 23. John, you're so nice. And we get x equals minus 1. I'm going to write it right in the middle. Sometimes I do this. I do this a lot in the higher level classes. This is a piece of information that is not the answer, but it's very important to the next step of the problem. So I squiggle it so that my eye can easily find that information. And that's the perfect illustration of what we want to do. Now we need to use this to go back and use one of these 4 equations to solve for y. I like b this time. So I'm going to do 3 times minus 1. We're using substitution now, aren't we? Minus 4y equals 1. This is minus 3, so I'm going to add 3. And look what amazing thing. That canceled. Minus 4y equals 4. John, thank you. So y equals minus 1 also. And now I will write up here where I have a big glorious corner that our answer is the point minus 1, minus 1. And guess what? It's correct. All right, you are officially introduced to elimination. Like I said, for the next little while, John will tell you in the problems whether to use substitution or elimination. We will follow his lead. And even though I know right now you're thinking, ew, elimination, I'd rather substitute. That seems more fun to me. Trust me, once you get the hang of this, they will both be your loving friends. So let John force you to use it, and soon enough, you'll love them both. They both have their places. They both have their times. Depending on what the system looks like, we'll talk about that a little bit more. You can choose elimination or substitution based on how this looks, right? As you can see, for example, elimination works just fine when everybody's got a numeric coefficient. If we tried to substitute in this system, we'd have a mess because there are no letters with just a plain 1 in front of them. So elimination has its merits. I love it. I hope someday to be riding on the bus and sit behind you and have you talking with your friends about which you love more. Okay, done. Goodbye.